Recording in progress. So guys, we are starting with exercise 11C, question number 10. Okay. The area of the circle is increasing at a uniform rate of 5 centimeter square per minute. Okay. So the area of the circle is increasing. So the area is changing over a period of time at a uniform rate. That means the rate at which the area is changing, rate at which the area is increasing, that is constant, uniform rate. That means it's constant. So dA by dt, this is equal to constant and this rate is equal to 5. This rate is not going to fluctuate. It is not going to change. It will remain the same. Okay, this is given to us. Right? Now see, area is nothing but pi r square. Area is nothing but pi r square. So I'm replacing this area part with pi r square. Okay. Take pi outside. Derivative of r square is twice r d by dt of r. Twice r d by dt of r. Okay, because of the chain rule. And here I have applied x raised to n formula. Right? And since we are differentiating with respect to time, because anything changes with respect to time, over a period of time it changes. Okay, so t is r. This particular r is supposed to be t. Okay, so that's the chain rule over there, d by dt of r. So dr by dt is equal to, next slide, dr by dt is equal to 5 upon 2 pi r, equation number 1. So this is the amount of information that we get from the first line. Area is going to change with respect to time, and that is constant rate, uniform rate of 5. Okay. I replaced a with pi r square, and then pi is a constant, it went outside. D by dt of r square is 2r, d by dt of r. Okay. Now many students, they do a mistake, is like they derivate 5 and make it 0. That's not the case. It's already derivated. This is already derivated. So don't derivate the right hand side. Okay. Yeah. Now they are saying initially the circumference is 40 centimeter. So C is equal to 2 pi r. This we know. The C part, the circumference is 40 centimeter, which is equal to 2 pi r into r. 2 pi into r. R is equal to 40 upon 2 pi. Okay. R is equal to 40 upon 2 pi. So this is equation number 2. The initial circumference is 40 centimeters. Okay, that's given in the problem in the last line. Now they are asking you the rate at which radius is increasing. So how the radius is changing, how the radius is increasing, this is what is asked. Okay. Now after this particular step, what am I going to do is I am going to put equation number 2 in equation number 1. Okay, put the value of radius which is in equation number 2, put it in 1. Right? So dr by dt, put 2 in 1, dr by dt equal to 5 by 2 pi, that will remain as it is, and r is going to get replaced with 40 upon 2 pi. So 5 by 2 pi and r is 40 upon 2 pi. Okay, so this 2 pi will get cancelled, so this will be 1 upon it, and that is what is the answer. Dr by dt is equal to 1 upon it. So the change in radius, and there is no negative sign over here, that means the radius is also increasing. Okay, and common sense, if the radius is increasing, so is the area, so the area increases. Now rate of change of radius with respect to time, so the radius units are centimeter over here. Okay, and time unit is minutes, so put centimeter per unit over here, per minute over here. Okay, I hope you understood this problem. Question number 10, this was. Any feedback? Any feedback? Okay. So next problem is question number 14. Question number 14. Okay. Question number 14, sub question 1. Yeah. The side of the equilateral triangle is a centimeters long and is increasing at a rate of k centimeter per hour. So side is a centimeters and the increase in the side, that means the side changes at a rate of the change in slide, the change in side. The side is changing with respect to time. So d by dt of side. Okay, this is also given. K centimeter per hour. So both these things are given. Okay. Now in the second equation, I'll replace this side by A. Therefore, dA by dt is equal to K. Okay, this is the inference. The side is A centimeters. The change in side. When I say change in side, that is because it's mentioned in the problem the side is increasing. So side increases over a period of time. Over a period of time. So d by dt of side is equal to K. That is also given to us in the problem. Okay, so we need to find out how fast is the area changing or increasing. So in this particular problem, we need to find out dA by dt, how the area is changing or increasing. This problem will certainly give us increasing because the side is also increasing. Fine. Now A, that is the area of an equilateral triangle, is root 3 by 4 side square. Okay, root 3 by 4 side square. Okay, so A is equal to root 3 by 4 into A square, because the side is A, small a. Now the area changes, the area also increases because the side is increasing. So differentiating with respect to t on both the sides. Differentiating with respect to t on both the sides. Okay. So dA by dt, root 3 by 4 will go outside. A square will be 2a into d by dt of anyone? D by dt of a. Okay. So root 3 by 2. Fine. So this is 2 ones are 2 twos are root 3 by 2 a and dA by dt. See, look at the previous slide. dA by dt is k. dA by dt is k. So this will be root 3a by 2k. Okay. So this is dA by dt. We'll put the units. Since this is area and the side is in centimeters, so this will be centimeter square as per hour. The problem mentions hour, so we'll be using per hour instead of per minute or per second. So we got the answer. Okay. Now the second sub question of 14. The second sub question of 14 is related to the first sub question itself. It is very simple. I'll take you to the second sub question now. The sides of the equilateral triangle are increasing at a rate of 2 centimeter per second. So let the side be A. Let side be A centimeters. Okay, so the side is changing. So side changes over a period of time. So dA by dt, this rate is given, this change is given. That is 2 centimeter per second. This is given to us. Okay. And the initial side is 10 centimeters. A is equal to 10 centimeters. This is also given at the end of the problem. See, find the rate at which the area increases when the side is 10 centimeters. Okay, so we need to find out dA, capital A by dt. Capital A is the area, small a is the side. So how the area increases? The sides are increasing, so the area will also definitely increase. So they are asking dA by dt. Fine. I hope everybody has copied this. Now A is equal to pi r square. Sorry, I'm really sorry. Area of an equilateral triangle is equal to root 3 by 4 into side square. Okay, root 3 by 4 into side square. Now side we have taken as A. So let's put the value of side as A. Replace side with A, small a, root 3 by 4 into A square. Now the area and the side, they both are changing with respect to time. So differentiating with respect to t on both the sides. Differentiating with respect to t on both the sides. A square. So dA by dt, root 3 by 4 outside. Okay, root 3 by 4 outside. A square, derivative of A square is 2A dy dt of A. So it's like the previous problem. Same thing we have done. Same thing we have done. Root 3 by 4 into side square. Let side is A and then we have derivated this. Same thing. Okay. So dA by dt is equal to, now this two ones are two twos are root 3A by 2, root 3A by 2 dA by dt. Now, fortunately, in this particular problem, they have given the specific values. The initial side is 10 centimeters, so A is 10, and dA by dt is 2. All these values are given in the problem. I'll show you the previous slide. See, dA by dt and A is 10. So that you put after derivating, or don't put it before derivating. Okay. So this 2 and this 2 will get cancelled. So this will be 10 root 3. Okay. So dA by dt is equal to 10 root 3 centimeter square per second. Centimeter square per second. Okay. Any feedback on the problem number 14, first subpart and second subpart? Have you understood both the problems? Both were related to each other. Any feedback? Can you share some feedback? Are you understanding this? Please share your feedback over here over the chat box. Yeah. Next one. Let us go to question number 15. Please read the problem once so that there is no confusion later on. Question number 15. The diameter is 10 centimeters of a right circular cylinder. D is equal to 10 centimeters. So R is equal to 5. Radius is equal to 5. Okay. Altitude. Altitude is the perpendicular height of the right circular cylinder. H is equal to 20. H is equal to 20. Fine. Now, radius and height, both the things we have got. Okay. The diameter is increasing at a rate of 2 centimeter per second. So the change in diameter with respect to time, okay, this is equal to 2. This is given to us, but then diameter is equal to twice radius. Okay, diameter is equal to twice radius. So I'm replacing diameter with 2 times of the radius. Okay, so take this 2 outside. 2 d by dt of r is equal to 2. So dr by dt is equal to 1 centimeter per second. Okay, it's 1 centimeter per second. So from this statement, we have got this particular thing. right? Okay, dr by dt is equal to 1. Fine. Any confusion on this particular slide? Given diameter was 10, so radius is 5. H is also given as 20. H is the altitude, perpendicular height of the right circular cylinder. The diameter is increasing at a rate of 2 centimeter per second. So diameter increases with respect to time. So change of diameter with respect to time. So d by dt of diameter is equal to 2. This is also given. After that, I am replacing diameter with 2r. Replace this diameter with 2r. Take 2 outside since it's a constant. Cancel 2 on both the sides. You will get dr by dt is equal to 1. Okay. Now they are saying, how should the altitude change? What change in altitude will keep the volume constant? Okay. So they're asking dh by dt, how this should change, how the height will change to keep volume constant. We have to keep the volume constant. So volume is equal to volume of a right circular cylinder. That particular thing we need to write down. Pi r square h. Okay. Pi r square h. Okay. Differentiating with respect to t on both the sides. D by dt of v, d by dt of pi r square h. Okay, so dv by dt, take pi outside, d by dt of r square h, d by dt of r square h. Now in the right hand side we are going to apply u into v rule because radius and height both are changing and we need to find out the change in height. Okay, radius is already changing, we have calculated that. Okay, now one thing I just want to know, if you have read the problem, look at the last line. What change in the altitude will keep the volume constant? So we have to keep the volume constant. So if there is no change in volume, so what is the value of dV by dt? Think in the right direction and tell me. If there is no change in the volume, volume is going to remain constant. So volume is not going to change. So what is dV by dt? Anyone? This is technically very important. So guys, dV by dt will be 0. dV by dt will be 0 because volume is not going to change. Volume is going to remain constant. So if it is a constant, its derivative will be 0, right? Have you understood this point? Now this point was very, very important. Have you understood this point? Why dV by dt is 0? Any comments? Please share a feedback. Have you understood this? Hello, hello. Yeah. So volume is not going to change. It is going to remain constant. So the derivative of a constant is 0. Next step, I'll take pi on the left hand side. I'll divide it 0 upon pi. Right hand side, I'll just apply product rule. H d by dt of r square d by dt of h. Okay. So 0 is equal to h 2r dr by dt plus r square dh by dt. Okay. Now all these values we have except dh by dt. So h is 20 into 2 into r is 5, dr by dt is 1, r again it is 5 into dh by dt. Okay, so 0 is equal to 200 plus 25 dh by dt. Okay, see left hand side I have done product rule along with chain rule over here, and then I'm simply putting the values of h, r and dr by dt. The only unknown value is dh by dt that we have to calculate, so it is not known. But in all these values which I am marking in green right now, these values we have right from the beginning, and dr by dt also we have calculated. So I'm just putting all these values one by one. Okay, So minus 200 is equal to 25 dH by dt. So minus 200 upon 25 is equal to dH by dt. So minus 8 is equal to dH by dt. So the height is decreasing. Why decreasing? Because we got a minus sign. Height is decreasing at a rate of minus 8 centimeters per second. Okay. The radius is increasing, the diameter is increasing. That should increase the volume also. But then they are saying we have to keep the volume constant. So to maintain the same value of volume, something has to decrease. So what is decreasing? The height is decreasing over here. Okay. Give me a feedback of this. Have you understood this problem? Yes or no? Please tell me. Others who are attending this particular session, have you understood this? Okay. So I'll just erase this and I will take up the last problem. That is question number 12. Okay. So a ladder 5 meter long is leaning on a wall. So this is a wall. Okay. A ladder is leaning on it. This is the ladder. It's leaning on the wall. Okay. The ladder is 5 meter long. The bottom of the ladder is pulled along the ground, away from the wall. So this ladder, it is moving on the right hand side or the left hand side? Can you tell me? The ladder is moving away from the wall. So it is moving towards the right or towards the left? Yes, correct. It is moving towards the right. Fine. So these things you should know. It is moving towards the right. Okay, this ladder is moving towards the right. The bottom is moving towards the right at a rate of 2 centimeter per second. How fast is its height on the wall decreasing when the foot of the ladder is 4 meter away from the wall? So the foot of the ladder, this is the foot of the ladder. It is 4 meter away from the wall. Okay. So let this be X, let this be Y. Okay. So they have given one rate. The ladder is moving in the right hand side direction. Okay. And the height is decreasing. Obviously, this ladder, when it will fall down, okay, the height, the Y part will decrease. So they are asking how fast is the height of the wall decreasing, on the wall decreasing of the ladder, if the foot of the ladder is 4 meter away from the wall. So initial distance between the foot of the ladder and the wall is 4 meters. X is equal to 4 meters. Dx by dt. The ladder is moving away from the wall at a rate of 2 centimeter per second. This is also given. We need to find out dy by dt. Okay, because y is the height. Okay, this tip of the ladder, the top of the ladder, it is coming down. It is coming down. So how fast it is coming down? So the y part is changing. Okay, the y part is height is changing. It is decreasing. So how fast it is changing? That is what they are asking. So they are asking dy by dt. Now step number one. Step number one, what we have to do is we have to apply Pythagoras theorem. X square plus y square is equal to phi square. Okay, x square plus y square is equal to phi square. Okay. Now x and y, this both quantities are changing. So we are going to differentiate this with respect to t on both the sides. Okay. So the next uh, slide, I'm moving on to the next slide. D by dt of x square plus y square is equal to d by dt of phi square. Okay. So 2x d by dt of anyone? 2x d by dt of, I'm derivating x square with respect to t. So 2x dy dt of x plus 2y dy dt of y equal to 0. Okay. So 2x dx by dt plus 2y dy by dt is equal to 0. Now we know these values. Okay. We know the value of x, we know the value of dx by dt. Okay. The thing that we are supposed to calculate is dy by dt. Right? Okay. So let us see how to calculate this. So 2 into x. What is x? Initial x is 4 dx by dt plus 2y dy by dt. Dy by dt we don't know. Okay. Now let us find out whether we know y or not. So guys, initially we don't know what is the value of y. Okay. But then from the diagram, can you tell me what is the value of y by applying Pythagoras theorem? Okay. So initially when x is 4, the hypotenuse is 5, the value of y initially the value of y will be 3. Okay, Pythagoras triplets. So it will be 3 as per Pythagoras theorem. So 8 dx by dt plus 6 dy by dt. Oh, sorry, dx by dt value also we know. Dx by dt is 2. It's given to us in the problem. Fine. See, dx by dt is 2. Initial value of y we calculate using Pythagoras theorem. Okay. So this will be 16 plus 6 dy by dt. 16 plus 6 dy by dt is equal to 0. So 6 dy by dt is equal to minus 16. Dy by dt is equal to minus 16 upon 6 minus 8 upon 3. Minus 8 upon 3. Okay. Now this negative sign indicates that y is decreasing with respect to time. That's what we discussed. The tip of the ladder will fall down along the wall. So the height will decrease. So that's why there is this minus sign. And the units will be centimeter per second because everything is expressed in centimeters and the time unit is meters. Okay. So just a second. I'll just yeah. So negative indicates that it is centimeter per second. Okay, it's falling. That's why. That's why there is this minus sign. Okay. Yeah. Thank you.